Alright, so on that sheet that I gave you guys for some practice problems to help you out, got this really difficult problem here. Here's number 2. I drew the diagram up here on the board. I know it doesn't look excellent, man, it looks pretty bad. That 2 needs some help. That'd be a 2. Anyway, so this is what the question reads. The question reads, number 2, find the net force on the system below. Make sure to give magnitude, direction, and the angle from the positive x-axis. So we're trying to find out what the net force on this whole system is. And this is as simple as it's going to get. You just got 4 triangles. That's all you're dealing with, are just 4 triangles. Here's the red one. Go from here, over, from there, up. And you're going to make this right angle. So there's your first triangle. Here's your second one. From the center point, out, from there, up. And you make another right angle. And it goes the same thing for the other ones. Stuff we've done 1,000 times in class. Y'all can make a comment to me about how bad that looks later on. And same right here, come out to here and to there. And there's my right angle. So what we have are these 4 triangles. So what we're trying to do is you cannot add these forces, but we can add their x and y components. So we're going to break them into the subvectors for the x and the y components, and then we're going to add all of them together and we're going to see where they go. For this case, I'm going to keep everything as you typically do on your Cartesian system. I'm going to keep to the right as positive and up as positive. So, only thing to do is start breaking these triangles down. So let's just start. We'll go around counterclockwise, start with quadrant 1. So first one, our triangle is here. So let's make us our triangle really fast. There's my right angle. I have a 58.3 degrees angle there in the bottom left, and this hypotenuse is at 735.6 newtons. Alright, so now I've got to find these x and y components, and all I'm looking for is right here. I'm looking for the force sub x and the force sub y. So we're going to start doing that. I need a calculator. I got myself a calculator, and here we go. Let's start doing these. So I'm going to jump ahead because you've seen me do this time and time again in class, and just to save time on this video so you guys don't have to watch every single little step, I'm just going to jump straight into this because I know that the sine of 58.3 degrees in this case will be equal to f sub y over the hypotenuse. So I know if I'll just multiply by that hypotenuse, I'll get f sub y by itself. So f sub y is equal to 735.6 newtons times the sine of 58.3 degrees. We've done this time and time again in class. I'm just jumping ahead to save time. So I'm going to find force of x. Force sub x is equal. In this case, it's going to be the cosine, because if I'd have cosine of the 58.3 degrees is equal to the adjacent side, which is f sub x, over the hypotenuse. So it is equal to 735.6 newtons times the cosine of 58.3 degrees. Please do me a favor and make for sure to look at your triangle. Just do not just jump into this thing, because it's simply a careless error to mess up right here. You guys have done trig, you passed trig, you knocked it out of the park, you're doing trig again. Don't mess up on the trig portions of this. So now we're just going to punch this into a calculator. And we're going to find, let's do 735.6 times sine of 58.3 58.3 degrees. And that will be equal to 625.8567 newtons. And it's positive because it's in the positive y direction. Force sub x, only thing we're going to change around is going to be a cosine of that 58.3, and it'll be equal to 386.5369 newtons. So now I found these x and y components for there. So I can start just adding these all together once I do it for the other triangles. But you've got to do it for the other triangles. So we're going to save this information for later. So I'm going to put a little box around it, let me know. And then I'm going to move on to my next triangle. So we're going to go into quadrant 2 now. So here's quadrant 2, and here's our triangle in quadrant 2. So I'm going to make this triangle here. So I got my right angle right there. And then it has an angle of 52.6 degrees here at the bottom. And its hypotenuse is equal to 116.0 newtons. So, same thing like we just did. You're just going to keep repeating the same steps. We have a force of sub x and a force of sub y. Same thing as we've done before, but we're coming from this angle here, so I'm going to find the force of sub y is equal to opposite over hypotenuse, so it's force of sub y divided by 116.0 newtons. So I'm just going to multiply by that hypotenuse with the sine of that angle. So it's 116.0 newtons times, I did the opposite over hypotenuse, so it's the sine of 52.6 degrees. And f sub x is exactly the same thing but with the cosine. So there's that. And the reason I got f sub x is equal to 116.0 newtons times the cosine of 52.6 is because the cosine is the adjacent, which is f sub x, divided by the hypotenuse, which is 116.0 newtons. So then I'll just multiply by that hypotenuse and it'll get f sub x by itself. And we'll do what we've done so far. We're going to punch this into our calculator. So let's just punch that in really fast. It's going to be 116.0 times the sine of 52.6, which will be equal to 92.1521 newtons. And it's positive because it's in the positive y direction. So it's going up. As you can see back here, it's going up, so we're okay. So it's positive, we'll save that for later. And then we have, going back to what? Down here to find f sub x. Here at the bottom, f sub x is equal to 116.0 newtons times the cosine of 52.6. And that'll be 70.4556 newtons. Now the key to this one is that's negative. It's negative 70.4556 newtons because it's going in the negative x-axis direction. Alright, now we're going to move on from there and we're going to go to our quadrant 3. This is our big triangle. He's big. He's very wumbo. Look at him. So I'm going to slide over here. So this is what we'll do. Same thing we've done before, just make our triangle. That is not drawn to scale, close enough though. Well, that sucks, huh? That didn't give me any room to write. Here we go. This is better. my right angle's right there, and then I have this angle is 81.2 degrees. Alrighty. So I have a hypotenuse, which is right here, which is equal to 1,186.9 newtons. So now I'm going to try and break this down. Just like we've been doing the whole time, we're just going to keep doing it. So here's the force of sub y, and here's the force of sub x. So, just like we've done before, it's going to be the force of sub y is equal to, it ends up coming from this angle, is the opposite f sub y over the hypotenuse, which is 1,186.9 newtons. So, we're going to multiply by that hypotenuse, just like we've done before, to end up giving us 1,186.9 newtons times the sine, because we did opposite over hypotenuse, the sine of an 81.2 degree angle. And then the f sub x is the same thing, but we're going to change this to the cosine of the 81.2 degree angle. And the reason we're doing that is because in here it's the adjacent side. So the cosine is adjacent over hypotenuse. You guys should be knocking this out by now. So we're going to punch that in the calculator, find it out. We're going to do 1,186.9 times the sine of 81.2. That'll give us 1,172.9283 newtons. And it's negative this time because it's going in the negative y direction, which we can see right here. So it's the negative direction. So it'll be negative then force sub x. The only thing that changes is on that angle, we're going to do a cosine instead. So it's going to be 181.578 newtons. And it's negative as well. The reason it's negative is because it's going in the negative x direction. So they're both negative, but we're going to save that information for later as well. So now, we only got one more triangle to do this with. So our last triangle right here is a little small guy. So let's see here. There's my right angle. I got this angle here is 12.9 degrees. And my hypotenuse is equal to 948.12 newtons. And now we're just going to do what we've done before. We're just going to keep breaking it down. That's it on there, right? So we're going to do the force of sub x, and we're going to do the force of sub y. So we're going to keep doing what we've been doing. Force of sub y is equal to opposite over hypotenuse. We're going to multiply by hypotenuse. You've heard me say this over and over again in class and over again in this video. So f sub y, it will be equal to 948.12 newtons times the sine, okay, of the 12.9 degree angle. And then you got force sub x is equal to, same thing, 948.12 newtons, but instead of sine, it's cosine. So the cosine of 12.9 degrees. And we're going to punch that in the calculator and see what we get. So 948.12 times the sine of 12.9, and that's equal to 211.6679 newtons. This is negative. Why is it negative? You guessed it. It's going in the negative y direction. And then find f sub x here. Only thing that's changing is we're going to do the cosine instead of the sine of that angle. And it'll be 924.1906 newtons. And it's positive. The reason it's positive is it's going in the positive x direction. So now you've gotten all the information, you've broken all these down to the positive, negatives, and the x and the y components. So now it's as simple as this. We're just going to do a summation of them all. You're going to do a summation of the x components, and you're going to do a summation of the y components. So let's do that. I'm going to erase this diagram now because we no longer need it. So the summation, so let's do the net force. Let's do the x components. So let's do all the x components. The first x component is 386.5369 newtons, and we're going to add to that the others. So going from there, let's go to this one, and we're going to have a negative 704.556. Whoa, I apologize. That is not 704. This next one is negative 70.456 newtons. We're going to add to that. Continuing right on, this x component, which is negative 181.5789 newtons, and add along with that our last x component, which is 924.1906 newtons. All of this is the x components of every one of those forces. Every one of those triangles we broke down. So triangle 1, triangle 2, triangle 3, and triangle 4. Every one of them, that's all we've done to it. So now we're going to add them together. We're going to find our x component. So 386.5369. And we're going to add to that negative 70.4556 plus negative 181.5789 plus 924.1906. And we're going to find that our x component is equal to 1,058.693 newtons. So there's my x component. And I got to find my y component. So force, net force of the y component. And we're going to do what we've done for the x's, but we're going to do it for the y components now. So just add all the y components together. First y component I have is 625.8567 newtons. We're going to add along with that 92.1521 newtons. That's the y component from the second triangle here. Third triangle is going to be a negative 1,172. Yeah, 72.9283. 9283 newtons plus a negative 211.6679 newtons, which will be equal to, so let's see, let's add them all together, 625.8567 plus 92.1521 plus a negative 1,172.9283 plus a negative 211.6679, and that'll give us negative 666.5874 newtons. So now I have my net force components, the X and the Y components. So now we are got the information, we can finally finish this question. Thank you, Jesus. So we're going to erase this so I can draw me my Cartesian system and get this answered. Alright, so I need a new Cartesian system. Here's my new Cartesian system, and now we're going to solve and find what our net force would be. So, let's do it. First, I'm going to start with, let's see. Yeah, I'm going to do the X. I'm going to do the X first. You can do either the X component or the Y component. It doesn't matter. As long as you do tip to tail, you're fine. So, I'm going to do the X component. I'm going positive. So, I'm going over. And it is 1,058.693 newtons. And then from there, I'm going to do the Y component, which is negative. So I'm going down 666.587 newtons. And then I'm going to want to end up with, what I'm trying to find is this resultant vector between these two right here. So I'm trying to find this purple here. So there's the net force. So you've seen us do it 1,000 times in class, Pythagorean theorem. The net force is equal to the square root of, it'll be 1,058.693 newtons squared plus 666.5874 newtons. That whole thing squared. It is a negative before anybody wants to make a comment or anything. I know it's negative. Not naming any names. Travis! So it's a negative. You're going to do this in your calculator really fast. Alright, so we're going to do the square root of, and let's do 1,058.693. Square that, and we're going to add with that a negative, because it's got to be negative, Travis, right? 666.5874 squared. And we'll find that our net force is equal to 822.4914 newtons. Now we're not finished, because we just found the magnitude, and we're given direction here. So on this, we got to carry on, and we got to find this angle right here. We'll call it big theta. So to find that, the first thing I got to be able to find, I got to find this angle right here. I'm going to call it beta. So this is what I'm going to do to find the angle of beta. I'm going to do the tangent of beta is equal to the opposite, which is 666.5874 newtons. I didn't put a negative there because we're solving it like it's a triangle right now. 666 there is the opposite over the opposite over adjacent. I apologize. Opposite over adjacent, which is 1,058.693 newtons. So beta will be equal to the inverse tangent of 666.5874 newtons divided by 1,058.693 newtons. Newtons are canceled. That's a good thing, so I want to be left with degrees. So we'll find inverse tan 666.5874 divided by 1,058.693, and this angle beta is equal to 32.1958 degrees. Still not finished. I've only found the last piece of information to get my full-on answer. If I want to get theta, so theta will be equal to 360, because if I go all the way around, it'd be 360 back here. 360 degrees subtracting beta, which will be equal to 360 degrees minus the 32.1958 degrees, and that'll give me my angle to be, let's do 360 minus answer 327.8042 degrees. So here's the two components to the right answer. So our net force is a magnitude of 822.4914 newtons at 327.8042 degrees. Woo! That's a good question. Man. So this is the answer to number 2. And number 3, where it says from the above figure from problem 2, what would be a third force that should not say third force, that was bad of me. What would be a fifth force? I apologize. Say what would be a fifth force that would make the system be in equilibrium? All you got to do is equal in magnitude, opposite in sign. You'll have to change this x component to a negative and change that y component to a positive. Just change the signs on them and do what we just did, and you're done. You'll get the answer for number 3. If you guys have any questions, come and see me during first lunch or at the beginning of the day at 7:05 when school opens. If not, see you later.